It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Good evening, friends. Welcome to Unacademy GATE ESE. This is your educator Aprup Rao and you are watching the lecture series of machine design. This is lecture number 11, design of clutch part 1. Yes, we are starting the design of clutch in today's session and we are going to see the design of all types of friction clutches. Very important chapter from exam point of view. There can be theory questions, there can be numerical questions. Good evening, good evening, good evening. Welcome, welcome, welcome. Good evening, Praveen. Good evening, Bala. Good evening, Ankita. Good evening, Kalpesh. Good evening, Ayush. Welcome all of you. Welcome all of you. So, beta, this is your educator Aprup Rao, and this is a part of the crash course, 100 days crash course for GATE 2021. We started it on 1st of October. I have already completed one subject, strength of materials. If you want, you can watch the playlist of strength of material. Entire subject is there, entire syllabus of strength of material has been covered, and this is the lecture series of machine design. Again, we are going to cover the entire syllabus. We are not going to skip anything, and in this lecture series I am going to cover all the theory, I am going to cover all the numericals, I am going to solve all the PYQs here itself. So this will be a single source of machine design for your preparation for GATE 2021. GATE 2021 के लिए अगर आप प्रिपेयर कर रहे हैं तो ये आपके लिए सिंगल सोर्स होगा मशीन डिजाइन की प्रिपरेशन के लिए. आपको इसके अलावा और कोई सोर्स की जरूरत नहीं पड़ेगी, ना कोई वीडियो लेक्चर देखना पड़ेगा, ना कोई बुक खोलनी पड़ेगी. दिस विल बी अ सिंगल सोर्स. नो नीड ऑफ एनी बुक्स, नो नीड ऑफ एनी लेक्चर्स अपार्ट फ्रॉम दिस. So beta, in this lecture series we are going to cover everything, theory from very basics, from zero, then numericals, different types of numericals, then PYQs, all the previous year questions of GATE I will solve in the class itself. Okay, so welcome all of you. Please hit the like button and please share this link with all your groups, WhatsApp groups, Telegram groups, जहाँ पे भी आप share कर सकते हैं, please share कर लीजिए. Okay, now if you are watching me for the first time, let me introduce myself. My name is Aprup Rao, All India rank 320 in GATE Mechanical. I've done my MTech from IIT Kharagpur and my specialization was Mechanical Systems Design. In my final year, I was recruited by Mahindra and Mahindra and I was placed at their research and development center called Mahindra Research Valley, where all the cars of Mahindra are designed, XUV, TUV, KUV. I was a part of different types of projects there. Then after 2 years, I decided to quit my job and I started teaching. So I've been teaching for more than 6 years now for GATE and ESE, and I teach subjects related to design, strength of materials, machine design, engineering mechanics, and theory of machines. But this is not the reason why I am here in front of you. I am here in front of you because of my love and passion for teaching, my love for the subjects of design. And if you have been following my lectures regularly, then I can guarantee that you will also fall in love with these subjects. If you want to see all my lectures in one place, if you want to download all the PDFs, if you want to download the ebooks, everything will be here in one place in well organized manner. tinyurl.com/approve10. Just open your browser, any web browser, and type tinyurl.com/approve10. Just like youtube.com, facebook.com, type tinyurl.com/approve10, enter, and you will go to this page. बेटा बस अपने वेब ब्राउजर को खोलो और ये टाइप कर दो search mat karo, don't search for this in Google, type this in your web browser and enter, and आपको ये folders देखने को मिलेंगे which contains the ebooks of all my classes. in folders में आपको सारी ebooks मिल जाएंगी. Then in Excel sheets में आपको सारा video lecture का content मिल जाएगा. You will find the links of all the video lectures on YouTube, on Unacademy in these Excel sheets. If you open any Excel sheet, for example, if you open the Excel sheet of strength of material, then you will see that I have organized all the lectures in this Excel sheet. I have uploaded the YouTube class link, I have given the PDF link, and I have also given the DPP link. What do we mean by DPP? Daily practice problems, where you will find additional problems, solutions of video solutions of additional problems. Okay, so open any of these Excel sheets and you will find the entire syllabus of that is covered in video lectures. You will find the lecture notes, everything. So if you want to prepare for the subjects of design, then everything related to that will be available here, tinyurl.com/approved10, completely free of cost. Completely free of cost. This is our way of giving back to the society. Okay, so beta, for your love and support, this is my way of appreciating you. Okay, and if you want to watch my special classes, just follow me on Unacademy. Again, open your web browser and type unacademy.com/@approved. This is my profile ID, @approved. So if you open this, you will go to my profile. You can watch all my special classes. I have taken special classes in different subjects of design, EM, SOM, MD. I have solved previous year questions of engineering mechanics. You will find previous year questions of strength of material, and from day after tomorrow we are starting previous year question series for machine design also. Okay, so if you are practicing the GATE questions of these subjects, then these lectures will be really helpful. Okay, now there is another very good news, very important news. We have started Unacademy Combat, which is India's #1 competitive test series, where you can win exciting prizes. You can win Apple MacBook, you can win AirPods, you can win iPad mini, and you can win 1000 rupees Amazon vouchers. Okay, so beta, we have gamified the test series of GATE. We have gamified the test series of GATE. This is the biggest combat ever on test series of GATE. So if you want to take part in this, I will share the details in tomorrow. I will be live at 3 PM tomorrow on YouTube with the details of Unacademy Combat. Okay, so if you want to understand more about this, then be live tomorrow at 3 PM on this very channel, and I will explain everything. Now, if you want to unlock these special classes, if you want to unlock Unacademy Combat, if you want to take part in Unacademy Combat, what you need to do is, step 1, download Unacademy Learning app. सबसे पहला काम, Unacademy का learning app download कर लो. You go to Play Store or Apple Store and you will get this app for free. Step 2, register yourself. You will just have to put your name, your email ID and your phone number, and you will be registered in Unacademy learning platform. And then step 3, in order to unlock these special classes, in order to take part in Unacademy Combat, you will have to put an invite code. You will have to put an invite code. And what will be your invite code? It will be approved10. Just approved10. If you enter this code, you will unlock all the special plans, all the free plans of Unacademy. You can take part in quizzes, you can take part in combat, you can watch the special classes of all the educators. Okay, not just my special classes, you can take part in special classes of all the educators using this code approved10. Okay, so do this right now, because this is going to be a big surprise for you. So beta, take part in this Unacademy Combat. Yesterday I gave you a problem to solve. This was your assignment. So I hope all of you have solved this question. Let's see what will be the solution. A differential band brake has a force of 220 Newton applied at the end of the lever as shown in figure. Coefficient of friction is 0.4. Angle of lap is 180 degree. Find the maximum torque that the brake may sustain for counterclockwise direction. Okay, so we have the braking force, we need to find the braking torque. Good evening Krishna, good evening Devi Karan, Akshay, Dibyanshu, Utkarsh. Please hit the like button and Please share the link with your friends. I want maximum number of students attending these lectures live. That will increase my level of energy. That will inspire me, motivate me, and that will increase my level of energy. So please do that for my sake. Okay. Now, let's calculate the breaking torque. We have solved this type of problem yesterday, but this was an assignment problem. I want to give you the entire solution. So let me give you the solution. So what we need to do is, first of all, we need to find T1 and T2. And how you will find T1 and T2? We have two relations, right? We have two equations to find T1 and T2. The first equation is this: T1 by T2 equals to e to the power mu theta. What is mu? 0.4. What is theta? Pi. Okay. So this is the first relation. The second relation we will get by taking moment at the hinge, right? Now this is counterclockwise rotation. Counterclockwise means anti-clockwise rotation. So if it is rotating anti-clockwise, then the braking torque will be clockwise. The braking torque will be clockwise, and if braking torque is clockwise, then what will be the direction? What will be, where will be the T1? Where will be the T2? This will be T1, right? And this will be T2. Now take moment at point O. Take moment at point O. What you are going to get? If you take moment at point O, moment of 220 will be 220 into 200. Then moment of T1 will be minus T1 into 100. And moment of T2 will be plus T2 into 50 equal to 0. So we have these two equations, equation number 1 and equation number 2. So by solving these, we will get T1, we will get T2. So quickly tell me what T1 and T2 you got. Jaldi batao ki T1 और T2 कितना आया. So beta, from this what I will get, e to the power 0.4 pi. So T1 will be 3.5135 times of T2. Okay. Now I will put it here. (146). T2 is 146. T2 I have got 146 and T1 513. Yes. T1 513, T2 146. Very good, Dinesh. Very good, very good, very good. So beta, I have got the value of T1, I have got the value of T2. Now all I need is this relation TB equals to T1 minus T2 into R. So 513 minus 146 multiplied by radius of drum. What is the radius of drum here? 150 mm is the diameter. So radius will be 0.075 meter. So TB is how much? 513 minus 146 multiplied by 0.075. So we have 27.525. 27.525 Newton meter. This is the braking torque. Yes. So this is the answer of yesterday's problem. Very good, Palak. Very good, Kalpesh. Very good, Ayush. Very good, Nitish. Very good. Very good. Yes. So this is the answer, 27.525 Newton meter. Okay. So braking torque by this differential brake will be 27.525 Newton meter for anti-clockwise rotation of the drum. Okay. So we have solved all the different types of problems related to brakes, shoe brakes, band brakes. Okay. Now in today's class we are starting the design of clutch, and it is a very important chapter from exam point of view. Design of clutch is important from theory point of view as well as numerical point of view. Okay. So let's understand design of clutch today. What is clutch? We all know what is clutch. But let's understand the technical meaning of clutch. Why do we exactly need clutch? Okay. So clutch is a mechanical device which is used to connect or disconnect the driving shaft and the driven shaft so that the driven shaft can be stopped without stopping the driving shaft. Understand? Let's talk about an automobile. एक ऑटोमोबाइल के पॉइंट ऑफ व्यू से देखते हैं, एक ऑटोमोबाइल के एग्जांपल से समझते हैं कि व्हाट इज क्लच. ओके, सो in case of an automobile, the driving shaft is connected to the engine and the driven shaft is connected to the wheels, the transmission. Okay, engine is producing power and the wheels are taking this power. Okay, so beta, driving shaft and driven shaft are not permanently connected. If you permanently connect them, then what will happen? Whenever you need to stop the wheels, you will have to stop the engine, and this you don't want. This you don't want. You don't want the engine to stop every time you need to stop the wheels. जब जब व्हील्स को स्टॉप करना है, जब जब आपको व्हील्स को रोकना है, आप नहीं चाहते कि बार बार इंजन को बंद करना पड़े. So what you need to do in that case? You will join the driving shaft and driven shaft using some temporary arrangement. There will be some temporary joint. तो ड्राइविंग शाफ्ट एंड ड्रिवन शाफ्ट को टेम्पररली कनेक्ट करने का काम कौन करता है? Which device is used to connect the driving and driven shaft temporarily? That is clutch. So beta, what will be the use of clutch? If you want to stop the driven shaft, just disconnect the clutch. So driving shaft and driven shaft will be disconnected. Driving shaft will be continuously moving, means engine will be continuously running, but your wheels will be stopped. Okay, I have the schematics of an automobile here. So you can see this is the engine part and this is the transmission part. Okay, this is the engine shaft, this is the transmission shaft, and both these are connected using a clutch. This is the clutch. Okay, so if you want to stop this transmission, just disconnect this clutch. The clutch will be disconnected and engine will be running, transmission will stop. So this is how the clutch works. This is how the clutch works. Okay, now what will be the objective of clutch? Objective of clutch will be to transfer the torque from the driving shaft to driven shaft. Okay, so beta, the entire design of clutch is based on the torque transfer. We need to transfer the torque. See, driving shaft is running, it is continuously rotating due to some torque, and driven shaft needs to be rotated. So you need to transfer this torque to the driven torque. So what will be the objective of clutch? Whenever you will connect the clutch has to transfer the torque from driving shaft to driven shaft. So a good clutch will be which will transfer maximum amount of torque. एक अच्छा clutch वो clutch होगा जो ज्यादा से ज्यादा टॉर्क ट्रांसफर कर सके ड्राइविंग शाफ्ट से ड्रिवन शाफ्ट की तरफ कम से कम साइज में. ओके, अगर आपको टॉर्क इंक्रीज करना है तो साइज बढ़ाना पड़ता है, तो इसीलिए आप नहीं चाहोगे कि जो टॉर्क ट्रांसफर कैपेसिटी हो वो कम हो. इफ द टॉर्क ट्रांसफर कैपेसिटी ऑफ क्लच इज लेस, then you will have to increase the size, and sometimes there is a limitation of size. So that's why you want maximum amount of torque transferred from driving shaft to driven shaft by means of clutch. Okay, so a good clutch is a clutch which transfer maximum amount of torque. Okay, now there are two main categories of clutch, although there are several types of clutch, but we can divide all the clutches into two main categories: positive clutch and friction clutch. Positive clutch and friction clutch. What is the basic difference between positive clutch and friction clutch? It is how the torque is transferred. It is how they are connected and how they transfer the torque. So beta, in case of positive clutch, the engagement of the two parts of clutch, there will be two parts of clutch obviously. One part will be connected to driving shaft, one part will be connected to driven shaft. Okay, so when these two parts are connected together, driving and driven shaft will be connected together. ठीक है, तो क्लच के दो पार्ट होंगे ऑब्वियसली, एक पार्ट ड्राइविंग शाफ्ट पे लगा होगा, एक पार्ट ड्रिवन शाफ्ट पे लगा होगा. जब ये दोनों पार्ट आपस में जुड़ेंगे तो ड्राइविंग एंड ड्रिवन शाफ्ट कनेक्ट हो जाएंगे. राइट, नाउ इन केस ऑफ पॉजिटिव क्लच, दीज टू पार्ट्स are engaged positively. There is a positive engagement between the two parts of clutch. What do we mean by positive engagement? Positive engagement का मतलब क्या होता है, यहां मैं आपको समझा देता हूं, because this term is used in different topics. This term is also used in gears. गियर्स जब पढ़ेंगे तो वहां पे भी आपको ये टर्म सुनने में आएगा, पॉजिटिव एंगेजमेंट. सो व्हाट डू वी मीन बाय पॉजिटिव एंड नेगेटिव एंगेजमेंट? पॉजिटिव एंगेजमेंट का मतलब क्या है? सी, let's say this part is rotating, okay, and this part is stopped, and I am connecting both these parts, okay. If there is no slip between these two parts, means this is rotating, this is also rotating with this part, both are continuously rotating without any slip, then this will be a positive engagement. And if this part is rotating but this part is stopped for some time, then we say that there is a slip. So this is not a positive engagement, it will be called as a negative engagement. Negative engagement wala term hum use karte nahi hai, because there is a positive engagement and then there is a slip, okay. So positive engagement means there is no slip. And when we will have positive engagement? In case of positive clutch, for example, we have jaw clutch. Positive clutch ka example is jaw clutch. So in case of jaw clutch, we have these teeth on clutches, ठीक है. Clutch में ऐसे teeth बने रहते हैं. So when these teeth will be connected together, then the engagement will be positive. There will be no slip because they both are connected together like this. So there will be no slip. Just like gears. In case of gears also we have matching teeth which are connected like this. So in gears also there is a positive engagement, no slip, okay. So beta, in case of positive clutch, there is a positive engagement between the clutches, and in case of friction clutches, there is no positive engagement of the clutch. The clutch are connected by means of friction. The torque is transferred by means of friction. Now, friction clutch के case में क्या होता है? Let's understand that. Okay, let's say this body is rotating continuously and this body is static. If I apply a normal force on this body, ठीक है, this body is continuously rotating. If I apply a normal force on this body, then this body will be connected to this body. There will be a friction force between them, which will oppose the relative motion, which will rotate this body also. So both these body will start rotating together. तो इन दोनों को जोड़ के कौन रखेगा? Which will rotate this second body? The friction developed between these two bodies. I am applying a normal force on this body. So there will be a friction force. That friction force will apply torque and this second body will start rotating. So beta, this is known as friction clutch. In case of friction clutch, there is no positive engagement. Now there are certain advantages and disadvantages of both the clutches, okay. Although mostly we use friction clutches only, in only some rare cases we use positive clutches. Mostly you will see friction clutches. In fact, in all the automobiles you will see only friction clutches, okay. But positive clutches are also there. It is not in our syllabus. In our syllabus we need to see only the design of friction clutch. But you need to understand about positive clutch also, okay. You need to know the difference between positive and friction clutch. Sometimes in theory they will ask you this question, okay. Sometimes in theory they will ask you questions from positive clutch also, but the numericals, the design process is only for friction clutch. There is only friction clutch in our syllabus, so you don't need to worry about the design of positive clutch, okay. So let me tell you briefly about positive clutch so that you will understand what is the difference between both, what is the advantage and disadvantage of both, ठीक है. मैं आपको briefly positive clutch के बारे में बता देता हूं ताकि आपको समझ में आए कि दोनों में अंतर क्या है, क्या दोनों का advantage है, क्या disadvantage है, okay. So let's talk about positive clutch. So बेटा, positive clutch के केस में the engagement is positive, means there is no slip. दोनों में कोई slip नहीं होता है, okay. Now there is a sudden engagement. What do we mean by sudden engagement? Understand, okay, because this term is also used quite often, so you need to understand what is sudden engagement. Sudden engagement का मतलब क्या है? Let's say this body is moving with 100 rpm, okay. This part of clutch is moving with 100 rpm and this part is at 0 rpm because it is static right now. When you will connect these two, this part will suddenly jump from 0 rpm to 100 rpm. In case of jaw clutch, the engagement will be sudden. So beta, this part will go from 0 rpm to 100 rpm. This is rotating at 100. This is at 0 RPM right now. When you will connect, it will go instantly from 0 RPM to 100 RPM. Okay. Now you will say that it's a good thing. It's a good thing, right? It is not taking time. It's a good thing. It is going from 0 to 100 like that. No, beta, it's a bad thing. Why it's a bad thing? Because, beta, if the speed will suddenly, instantly go from 0 to 100, what is going to happen? What is going to happen? There will be sudden shock and vibration. There will be shock and vibration. This clutch will start vibrating. The entire machine will start vibrating. And you don't want that. आपको वो नहीं चाहिए, right? So, beta, sudden engagement is not advantageous. We need smooth engagement. You want the speed to go from 0 to 100 smoothly, so that there will be no shock, there will be no vibration. So that is the disadvantage of positive clutch. Okay. So that's why whenever you are engaging a positive clutch, you need to reduce your speed, because at high speed there will be very high vibration and shock. It will create noise, it will create wear and tear. Okay. At low speed also there will be shock, vibration, wear and tear, but at high speed it will become very deadly. So that's why it has to be connected at very low speed. तो बेटा positive clutch का disadvantage क्या है? Positive clutch के disadvantage है that when it is connected, the sudden engagement is sudden, so there is shock and vibration. Now you will ask me, disadvantage तो गिना दिया, advantage क्या है? What is the advantage? The advantage is here there is no limit of the torque transfer. You can transfer as much torque as you want, because the torque transfer is due to positive engagement. Okay, so there is no limitation apart from the strength. Strength is the limit. Okay, आप बहुत ज़्यादा torque लगा दोगे तो क्या हो जाएगा? ये टूट जाएगा ना. So apart from strength, there is no limitation. Okay, in case of friction clutches, apart from strength, friction is also a limitation. ठीक है, strong तो आपने बना दिया, torque झेलने के लिए strong आपने बना दिया, लेकिन टॉर्क ट्रांसफर डिपेंड्स ऑन फ्रिक्शन, तो फ्रिक्शन भी ज्यादा होना चाहिए ना. जितना फ्रिक्शन रहेगा उतना ही टॉर्क ट्रांसफर कर पाओगे. हियर देयर इज नो लिमिटेशन ऑफ फ्रिक्शन, so that is the advantage of positive clutch, but they are not used very frequently. They are used only in some rare applications like power press, rolling mill, etc. Okay, those are the applications of positive clutch where the engagement is positive, engagement is sudden. Okay. Now this is not in our syllabus, so you don't need to worry about the design process. Okay. So in our syllabus, we only need to deal with the friction clutch. Now what happens in case of friction clutch? In case of friction clutch, the power is transferred by means of friction. Okay. Now let me explain how it works. ठीक है, ये कैसे काम करता है मैं पहले आपको समझा देता हूं. Okay. So let's say we have these two parts. Let's say we have these two parts. Okay, this is getting rotated, this is rotating continuously, this is rotating continuously, and this is stopped. Okay, now what I am going to do is I am going to apply a force on this part. So these two parts will be connected. Okay, there will be a normal force between these parts, there will be a normal force between these parts like this. Okay, forget about this, just focus on this, because this is the driving part, it is rotating continuously, so don't worry about this. This is the part we need to rotate. Okay, so when I am applying a positive, when I am applying a force on this part, then both these parts are connected, so there will be some normal force between these two. एक normal force create होगा दोनों के बीच में, and this normal force will develop a friction force also, because there is a relative motion between them. This is moving part, this is static part, so there will be relative motion, so there will be friction also, there will be friction also, mu n. Now this friction will apply torque, this friction will apply torque on this plate, right? Understand beta, this will be a circular plate. Let's for example, let's consider that it is a circular plate. Okay, like this. Okay, so this was the side view, this is the side view, this is the side view, this is the front view. Okay, so normal force is acting like this and friction force is acting like this, friction force is acting like this, friction force is acting like this. What is this I am drawing? I am drawing the friction force mu n. I am drawing the friction force mu n. So beta, this friction force will apply a torque on this. The friction force is acting parallel to the surface. Normal force is acting perpendicular to the surface. Friction force is acting parallel to the surface. So this friction force will apply a torque like this, right? Friction force will apply a torque like this. So beta, due to this torque, this second body will start rotating. This second body will start rotating. So do you understand? Do you understand the concept of friction clutch? Do you understand the concept of friction clutch? In case of friction clutch, what happens? When we apply a force on this second part, this is the continuously rotating part, this is the static part. So when you will apply a force on this static part and this rotating part will press each other. There will be some normal force, there will be some friction force, okay? And this friction force will apply a torque on the center of this non-moving part. So this non-moving part, the static part, will also start rotating, okay? So here, what is rotating this second part? The friction force is rotating the second part, okay? How much torque you will get? You will get the torque mu n multiplied by r, okay? For example, mu n multiplied by r. So beta, you can see that in order to have high torque, the friction force should be high. So here the torque transfer depends upon the friction. In case of positive clutch, the torque transfer doesn't depend upon the friction. The torque is transferred directly by the force, okay? But here the torque is transferred through friction. So in order to have high torque transfer, you need to have high friction. So here the torque transfer is limited due to friction, okay? So beta, let's understand what are the advantages of and disadvantages of friction clutch, okay? So in case of friction clutch, there is a smooth engagement. Slip occurs during the engagement. What do we mean by slip? Slip का मतलब क्या होता है बेटा? During the engagement, what happens is, let's say it is rotating at 100 rpm, okay? And this is right now static. So when I will apply the force, okay, and when it will be starting to engage, जब ये इससे engage हो रहा होगा, initially there will be some slip. Why there will be some slip? Because beta, the friction force will not be enough in order to rotate this at the speed it is rotating, है ना? Initially मान लो partially इनको मैंने दबाया, ठीक है? Partially मैंने इनको दबाया क्योंकि मैं जैसे ही force लगाऊंगा ये धीरे धीरे engage होंगे, right? They will be engaged धीरे धीरे. So beta, when I will apply the force, when they are partially engaged, the n will be less, mu n will be less. So beta, less torque will be transferred. So this part will not be rotating at the speed this part is rotating. So there will be some slip. There will be some slip. But this slip will be only during the engagement. If they are engaged properly, after that there will be no slip. एक बार दोनों engage हो गए, उसके बाद slip नहीं होगा. Okay. There will be smooth engagement. Now what do we mean by smooth engagement? See, the speed of this second part will not go suddenly from 0 to 100. If this is rotating at 100, this is at 0. So when I will be applying the force, it will not go suddenly from 0 to 100. It will go 0 to 100 smoothly, gradually. So that's why the engagement is gradual, the engagement is smooth, and due to this, even if you are engaging it at high speed, अगर आप इसको high speed पे भी engage कर रहे हो, there will be no shock, there will be no vibration. So that is the advantage of friction clutch, that there is no shock and vibration during the engagement, okay? That's why they are used in high speed applications like automobile. Automobile में हमको इन clutches को high speed पे engage disengage करना है, तो वहां पे हम positive clutch use नहीं कर सकते. There we cannot use positive clutch. The speed is very high. So that's why we use friction clutch, okay? So beta, this is the advantage of friction clutch. Now you will ask me what is the disadvantage. Obviously the disadvantage is due to friction there will be limitation of torque, ठीक है? Torque transfer यहाँ limited है, बहुत ज़्यादा torque transfer नहीं करा सकते क्योंकि friction limited है. Second thing, if there is friction, there will be heat generation, there will be wear and tear, okay? So you will have to repeatedly change these clutches, okay? Repair these clutches, change these clutches, okay? Because after some time it will be worn off. So that's why we need to repair them, we need to change them time to time, okay? Now beta, friction clutches are of different types. So there are 3 types of friction clutches. plate clutch, cone clutch and centrifugal clutch. Then plate clutch are of two types, single plate clutch and multi plate clutch. Okay, we need to see the design process of all these three clutches. हमको इन तीनों clutches को पढ़ना है, तीनों का design process देखना है, plate clutch, cone clutch and centrifugal clutch. I will start with plate clutch, then I will move on to cone clutch, then I will move on to centrifugal clutch. Plate clutch and cone clutch are almost similar. Plate clutch and cone clutch are almost similar. Their construction is almost similar. Design process is almost similar. Everything about plate clutch and cone clutch is similar except the shape of the clutch. But centrifugal clutch is entirely different. So beta, plate clutch and cone clutch are very similar. So if you understand plate clutch, you will easily understand cone clutch. Centrifugal clutch is also easy, but the design is very different. Okay. So let's start with the plate clutch. And in case of plate clutch also, we have two types of clutches, single plate and multi plate. So we will understand single plate clutch first. Okay. Now this is the construction of single plate clutch. Understand the construction, understand the major parts of this clutch. So we have this driving shaft which is continuously rotating. Okay, this is continuously rotating. And this is the flywheel. The flywheel is attached to the driving shaft through these bolts. You can see the flywheel is attached to this driving shaft through this bolt. So flywheel is also rotating with the driving shaft. Okay. Now this is the driven shaft. So you can say that this is the input or flywheel or this shaft are the input and this is the output. I need to transfer the torque from this part to this part. इस shaft से इस shaft पे torque transfer करना है. And how that torque will be transferred, understand. There is a clutch plate connected to this driving shaft. There is a plate, circular plate. Okay, there is a hole on this plate. It looks like this. Okay, circular plate. Side view say it will look like this. Side view. This is the side view of the entire clutch. So beta, side view say you will see that it will look like a rectangle. Okay, so this is the plate. On both sides of this plate, there are high friction material. Why? In order to increase the coefficient of friction. Now, when this plate will be connected to the flywheel, then friction will be developed between the plates and the plate will also start rotating. So, how the torque will be transferred from this shaft to this shaft? Through this clutch plate. This clutch plate has high friction material on both sides. Okay. So, when I will press this clutch plate on this flywheel, flywheel is continuously rotating. Remember, it is connected to the driving shaft. So, it is part of the driving shaft. So, when this plate will be connected to the flywheel, this plate will also start rotating due to friction. Now, what will press this clutch plate? What will press this clutch plate? This clutch plate will be pressed by this pressure plate. So, we have this another plate called pressure plate which will apply pressure on this clutch plate in order to connect this with the flywheel. इस प्लेट को फ्लाईव्हील से कनेक्ट करने के लिए पीछे एक और प्लेट है, प्रेशर प्लेट, जो इसके ऊपर प्रेशर लगाएगा, इसको धकेलेगा, फ्लाईव्हील से चिपका देगा. फ्लाईव्हील घूम रहा है, मेरी प्लेट जो है फ्लाईव्हील के थोड़ा आगे खड़ी है, तो वो उसको वहां से चिपका देगा, तो ये वाली प्लेट भी फ्लाईव्हील के साथ घूमने लगेगी. ठीक है. नाउ दिस प्रेशर प्लेट इज कनेक्टेड टू दिस स्प्रिंग. So this spring is applying continuous force on this pressure plate. So by default it is connected. जो spring है वो pressure plate के ऊपर continuous force लगाए हुए है. This spring is applying force on this pressure plate. Pressure plate is applying pressure on clutch plate. So this clutch plate is connected to the flywheel by default. By default ये initially ये connected है. If you want to disconnect it, then you will apply force on this paddle. This paddle will apply force on this pressure plate, which will move this pressure plate back. जब मैं ऐसा फोर्स लगाता हूं, जब मैं ऐसा सेंटर पे फोर्स लगाता हूं, तो प्रेशर प्लेट पीछे आती है. इसका शेप कुछ ऐसा रहता है. The shape of this pressure plate is something like this. Sorry. The shape of this pressure plate is something like this. ठीक है. तो जब मैं इस पे ऐसा फोर्स लगाता हूं, तो प्रेशर प्लेट जो है ये सेंटर का हिस्सा आगे जाता है और ये हिस्सा पीछे आ जाता है. सेंटर विल मूव फॉरवर्ड, दिस पार्ट विल मूव बैकवर्ड. सो बेटा दैट्स हाउ it will be disconnected. That's how it will be disconnected. Okay, if you want to understand, you can see this image. You can see this part. You can see this part. So if I press this part will move forward and the rest of the part will move backward. ये सेंटर का हिस्सा अंदर दबेगा तो बाकी का हिस्सा पीछे आएगा. ठीक है, जैसे आप प्लेट के केस में आप देख सकते हो, प्लेट के सर्कमफेरेंस को अगर कोई पकड़ ले तो सेंटर का हिस्सा अगर आप दबाओगे तो सर्कमफेरेंस पीछे आएगा, राइट? सो दैट इज हाउ this pressure plate will be disconnected. If you apply force on the pedal will apply force at the center of pressure plate. So pressure plate's center will move forward, but this part which is pressing the clutch plate will move backward. So that's how it will be disconnected. So whenever you need to disconnect, you will apply force on pedal. By default it will be connected. जब जब disconnect करना है तब तक pedal दबाओ तो ये disconnect हो जाएगा. Okay. Now बेटा, in this image, you can see three major parts. What is this part? What is this part? Do you understand what is this part? This part is this blue color part, which is the flywheel, which is connected to the input shaft, driving shaft. So this is continuously rotating. What is this second part? What is this second part? This part is this part, clutch plate. This is the part which will produce friction, and this is the pressure plate. This is the pressure plate which will apply pressure on this clutch plate so that the clutch plate will press against the flywheel and friction will be developed. Now do you see this part? क्या आपको ये चीज दिख रही है? Do you see this? Do you see this? Do you see this? Do you see this? What is this? This is the coating of high friction material. This is the coating of high friction material. This is known as friction lining. It has high coefficient of friction. Why? Because if you want to transfer more torque, friction should be high as possible. That's why in order to increase the friction, we use a material which has high coefficient of friction. Okay, there is a coating. So you can see that this is friction lining. This is friction lining. Okay, there is a coating of high friction material on the clutch plate on both sides. Okay, so this is known as friction lining. Now you can see these springs. Here there is spring, this spring, this spring, this spring, this spring. This is just to dampen the vibration. There will be some amount of vibration also, right? So this is just to dampen the vibration. It has nothing to do with the torque transfer. It will not take part in torque transfer. Torque transfer का इससे कोई लेना देना नहीं है. That is just to dampen the vibration. Okay. Now beta, we need to design this particular thing. We need to design this particular thing. What particular thing? We need to design this friction lining. ये वाला जो part है, मुझे सिर्फ इसको डिजाइन करना है. Okay. I need to only design this friction lining. And what do I mean by design of friction lining? I need to see how much torque will be transferred for a particular inner radius and outer radius. There must be some relation between torque and the size of this friction lining ना. कितना बड़ा friction lining होगा तो कितना ज़्यादा torque transfer होगा, right? So there must be some relation between this R1 and R2 with the torque transfer. So I need to find that relation. मेरे को वो relation चाहिए ताकि मुझे पता चले कि अच्छा R1 और R2 इतना होगा तो इतना torque transfer होगा. So do you understand about the design of this friction lining, the design of the clutch? आपको clutch के design से मतलब समझ में आ रहा है क्या करना है? What do we need to exactly do? Right? We need to find some relation between torque and the dimension of this friction lining. Okay. Now, in order to find that relation, let's consider this friction lining. Let's say this is the center of the friction lining. This is the inner radius R1 and this is the outer radius R2. Okay. So what is R1 and R2? R1 is the inner radius of friction lining and R2 is the outer radius of friction lining. Okay, mu is the coefficient of friction which will depend upon the material of friction lining. So I will use a material which has high coefficient of friction. Okay, I have given you the chart of different materials and their coefficient of friction, right? In case of brakes, and I told you that this chart will be useful in case of clutch also. So beta, in that chart I showed you the coefficient of friction and the maximum allowable pressure. Okay, so beta, coefficient of friction should be high and maximum allowable pressure should also be high. Okay, now what is happening, understand. In order to engage this clutch plate, this pressure plate is applying some pressure, and in order to apply the pressure on pressure plate, spring force is applying some force. Okay, so spring is applying some force. This spring is applying some force. Let's call this force W. Let's call this force W. So what is W? What is W? W is the axial force of engagement. W is the axial force of engagement applied by spring. इस फोर्स को लगा कौन रहा है? इस फोर्स को लगा कौन रहा है? Who is applying this force? This force is applied by the spring. Okay, so this W force is applied by the spring. Now when I will apply this force, this clutch plate will connect with the flywheel. The flywheel and the clutch plate both will apply forces on each other, both will apply pressure on each other. Exactly. Okay, both will apply pressure on each other. Let's say this pressure is P and this is the maximum pressure. Okay, let's say this pressure is P. What is P? P is the pressure on the clutch plate or friction lining. Okay, now beta, this pressure has to be sustained by the material of friction lining. So whatever material you are using for friction lining, it should have high coefficient of friction and it should also have high value of allowable pressure. Otherwise what will happen, if you are using a material which has very high mu but it can sustain very less pressure, so when I will apply the force, when the spring will apply the force and pressure will be developed, it will break, simply break. So beta, it should have high coefficient of friction as well as high allowable pressure. Okay, so that's why I gave you that chart in order to see the materials should have high mu as well as high P. Okay, so this is the pressure on the friction lining. Okay, now when this pressure will be applied on this, okay, this, due to this normal force, the pressure into area will be normal force. Due to this normal force, there will be friction force on this surface. There will be friction force on this surface like this. Friction force will be developed like this, and this friction force will apply torque on this friction lining, right? This friction force will apply torque on the friction lining. So T is the torque transferred. Okay, now understand, in order to transfer maximum amount of torque, I will apply maximum amount of W, as much W as I can apply, as much pressure as it can sustain. जितना ज्यादा आप फोर्स लगाओगे उतना ज्यादा प्रेशर डेवलप होगा. तो आप कितना ज्यादा फोर्स लगा सकते हो? How much force you can apply? P allowable, up to P allowable. Beta, if this pressure will go beyond P allowable, then this friction lining will break. So how much force I can apply so that the pressure will become P allowable? Okay, now beta, at that point the torque will be maximum. Now I need to find the relation between all these quantities. I need to find the relation between all these quantities. So understand each and every parameter. R1 is the inner radius of friction lining, R2 is the outer radius of friction lining, mu is the coefficient of friction, and W is the axial force of engagement. P is the pressure on the friction lining, T is the torque transferred by the friction lining. I need to find out the relation between all these quantities. Now how I will find the relation? Understand. First I will find the relation between W and P, and then I will find the relation between P and T. Do you understand how I am going to find this relation? First relation will be by W and between W and P, and second relation between P and T. Okay. So beta, let's first derive the first relation between W and P. Now understand what I need to do in order to derive that relation. Okay. Understand. When I will apply this force W, the pressure will be subjected on pressure will be applied between the friction lining and the flywheel. This friction lining is not moving in x direction now, so summation of Fx must be 0. What will be the net force? W is the force in this direction, and this pressure will apply the force in this direction. So W will be equal to force by pressure. Now how I will calculate the force by pressure? Pressure into area, but pressure into area I can only do if the pressure is constant. Right now, do you know that pressure is constant or not? No, I don't know. So what I will do, I cannot consider this entire area. Okay, so I will consider a very small area. I will consider a very small area strip at a distance r of thickness dr. Okay, I will consider a very small strip at a distance r from the center, and the thickness will be dr. Now, for this very small strip, can I assume that the pressure is almost constant? Yes, I can assume that. I can assume that pressure on this small strip is almost constant. So if the pressure on this small strip is almost constant, then I can do pressure into area, right? So beta, right now I cannot find the relation between this entire W with entire P. So what I am going to do is, I will consider this very small surface. I will find the relation between W and P on this surface, and then I will integrate. Okay? So beta, first relation between W and P. Okay. So what is the area of the element? That very small element. Area of the element dA will be equal to how much? इतने small area element का ये जो पीला वाला area दिख रहा है, what will be this area? This is a hollow circle with very negligible thickness. So what will be this area? Can I write 2 pi r into dr? 2 pi r into dr. Yes, I can write it. 2 pi r into dr. Right? This is the area of the element. Now, for the element, axial force on the element. Axial force on the element dW will be equal to pressure into area. Why? Because element has very small area. So I can assume that the pressure is almost constant on that element. So dW force will be equal to pressure into area. I can't do this for the entire area. मैं पूरे area के लिए नहीं कर सकता, but small area के लिए I can do this. So this will be P into 2 pi r dr. So if dW is this much, what will be W? What will be W? W will be equal to integration dW, means integration P into 2 pi r dr from R1 to R2. This will give me the relation between W and P. But in order to find that relation, I will have to integrate this, and right now I can't perform that integration. Why I can't perform that integration right now? Because in order to perform that integration, I need to know how this P is related to R. अगर मैं इस इक्वेशन को इंटीग्रेट करना चाहता हूं, यहां R को R के रिस्पेक्ट में तो मैं इंटीग्रेट कर लूंगा, बट how this P will be integrated with respect to R. If you know the relation between P and R, for example, if P is constant, it will come out of the relation. If P is related to R with some equation, let's say P equals to pi R square into something, then beta I will put that relation here in terms of R and I will integrate it. So beta I need to know the relation between P and R, whether it is constant or linearly changing or parabolically changing. What is the relation between P and R? And right now I don't know that relation. So I will not integrate this relation equation right now. मैं इस equation को अभी integrate नहीं कर सकता क्योंकि मुझे P और R के बीच का relation नहीं पता. Okay. So beta what I am going to do right now, let's keep it this way. Now I need to find the relation between T and R. अब मुझे torque और R के बीच में relation चाहिए. Okay, I need a relation between T and R. So how I will find that relation? Understand beta? In order to find the torque transfer, I need the friction force. Okay, so I will do the same thing here also. I will first consider this very small element. Okay, so what is the normal force on this element? इस element पे normal force कितना लग रहा है? This is the normal force ना, dW. dW is the normal force on element. So what will be the friction force on element? Friction force on element, dF, friction force on element will be mu into normal force, right? This W is the normal force, baba. dW is the normal force on this very small element. So friction force will be mu into dW. Now that friction force is acting like this. Something like this, okay. Then beta, in order to find this torque, what I will do? Mu into dW multiplied by this distance. How much distance? R distance, right? So beta, mu into dW, if you put the value of dW, how much will it be? Mu into P into 2 pi R dr. Okay, this is the friction force. So beta, what will be the torque transferred? Torque transferred by the element dt will be equals to mu into, dt will be equals to dF friction force into R, means mu into P into 2 pi R square dr. Friction force multiplied by distance will give you the torque. Now this is the torque transferred by that very small area. I need the torque transfer by complete area. So what I will do? I will again integrate this relation. So integrate this, this will become mu into P into 2 pi R square dr from R1 to R2, from R1 to R2. So this is the torque transferred by the plate clutch. But again, in order to find this relation, I need to integrate it, and right now I can't integrate it. Why? Because right now I don't know the relation between P and R. So beta, in order to find that relation, what I need to do? Understand, exact relation we don't know. We don't know how exactly the pressure and radius will be related, but we have some theories. Okay, basically we have two theories. We have uniform pressure theory and we have uniform wear theory. So by applying those two theories, we can have a relation between P and R, and from that relation I can find the value of W and T. Okay, so beta, let's see what those two theories are. So first we will see uniform pressure theory. So what is uniform pressure theory? According to uniform pressure theory, when the clutch is new, I can assume that the pressure on the plate is constant. When the clutch is new, pressure is constant over the surface. Okay, so beta, if P is the pressure, that means that pressure is constant. You can see that the pressure is constant. This is the friction lining, this is the center, this is R1, this is R2. So beta, from R1 to R2 the pressure is constant, means the pressure is not changing with respect to R. The pressure is not at all changing with respect to R. So if the pressure is constant, then it will come out of the integration. So what you will get? W will be equal to integration P integration R1 to R2 2 pi R dr. Okay, so if you integrate it, you will get this P into 2 pi. This will become how much? R square by 2 R1 to R2, right? R square by 2 R1 to R2, 2 and 2 cancel. So you will get what? P into pi R2 square minus R1 square. So this will be the relation between P and W, right? This will be the relation between P and W. So this is the relation between P and W. Now I need the relation between T and P. So how I will get this relation? Again P will be constant. तो P को बाहर निकाल लेते हैं. So this will become T R1 to R2 2 pi, sorry mu भी है 2 pi integration R square dr. तो बेटा अब ये mu and 2 pi is also constant ना, they will also come out of the integration. This will become R cube by 3 from R1 to R2. So what you are going to get? You are going to get mu into P into 2 pi R2 cube minus R1 cube divided by 3. So this is the relation between T and P. Okay, so we have these two relations for plate clutch. This is a single plate clutch. This is a single plate clutch. Now understand beta, this particular torque relation is derived assuming that the torque is transferred only from one side of this friction lining. But practically you will see that the friction lining will be on both sides, right? Look at this. The friction lining is on both sides. So beta, if in exam it is not mentioned that friction lining is on both sides, then you use this equation. Okay, by default use this equation. By default use this equation. By default use this equation. But if it is mentioned that friction lining is on both sides, if it is mentioned that friction lining is on both sides, then what you will do? This torque transfer will get double. ये जो torque transfer है ये double हो जाएगा. So it will become 2 times of this mu into P into 2 pi R2 cube minus R1 cube by 3. Okay, so that's all you need to do. That's all you need to do. If the friction lining is transferring the torque from both sides, then just multiply 2 in this equation. Okay, so that will be mentioned in the question, don't worry about it. Okay, if you need to multiply 2, it will be mentioned in the question that the friction lining is on both sides or torque transfer is taking place from both sides. Something like that will be mentioned in the question. If nothing of that sort is mentioned, then don't consider that it is transferring torque from both sides. Okay, practically the friction line transfers the torque from both sides, but if it is not mentioned in the question, then consider only this equation. Don't multiply 2. Don't multiply by 2. By default don't multiply 2. ठीक है, by default 2 से multiply मत कर देना. Is it clear to everyone? Is it clear to everyone? Yes. चलो, तो बेटा this is the equation of pressure and torque W and torque according to uniform pressure theory. But uniform pressure theory is only applicable when the clutch will be new and the pressure will be constant. But once the clutch becomes old, as you will use the clutch, what will happen? The clutch will worn off. There will be wear on the surface of the clutch, and if there is wear on the surface of the clutch, the pressure will not be constant over the surface. Okay, so in that case we apply uniform wear theory. So in case of uniform wear theory, what do we assume? In case of uniform wear theory, that we assume that when clutch is old, rate of wear is constant. Rate of wear is constant, and rate of wear is proportional to W into R. Sorry, P into R. So P into R is constant. P into R is constant. ठीक है? So beta P is not constant. P into R is constant. What does it mean? इसका मतलब क्या है? इसका मतलब ये है कि when R will be minimum, P will be maximum, right? When R will be minimum, P will be maximum, and when R will be maximum, P will be minimum. So at R equals to R1, P will be maximum, and at R equals to R2, P will be minimum. Okay. Now, can I consider P into R as a constant C? Yes, I can consider that. Remember this, okay? I am assuming P into R is a constant value C. Okay? Now what I will do? I will put P equals to C by R. In the equation, I will put P equals to C by R. Now what is the equation of W? W is integration P into 2 pi R dr from R1 to R2, right? So in this equation, put P equals to C by R. So this R and R will be cancelled. Now C is a constant quantity. So that will come out of the integration. So it will become C into 2 pi. Okay. Integration dr. And if you integrate dr, I will get R. So what you are going to get? What you are going to get? W equals to C into 2 pi R2 minus R1. That will be the equation. W equals to C into 2 pi R2 minus R1. All of you who was watching, please hit the like button and share the link. ठीक है, जल्दी से मेरे भाई, क्योंकि मैं देख रहा हूँ आजकल बहुत कम बच्चे अटेंडेंस दे रहे हैं या बहुत कम बच्चे लाइव आ रहे हैं, जिससे मेरी एनर्जी भी धीरे धीरे कम होती जाएगी मेरे भाई. तो एनर्जी को भरपूर रखने के लिए आपका सहयोग चाहिए. ज्यादा से ज्यादा मात्रा में, ज्यादा से ज्यादा संख्या में प्लीज हिट द लाइक बटन and please share this link with all your groups. Let all your friends know about these lectures, what you guys are doing. You guys are my real source of information. Let everyone know about this. Yes. Now beta, W equals to C into 2 pi R2 minus R1. Okay. Now we need a relation between T and C also. So how we are going to get that? T equals to what? Integration R1 to R2. C into mu into, mu into P into 2 pi R square dr, right? So here also I will put P equals to C by R. I will put P equals to C by R. So put P equals to C by R 2 pi R square dr. Okay. So beta, what you are going to get here? Mu into C into 2 pi will come out. This will become R, and if I integrate R, I will get R square by 2 from R1 to R2. So what I will do? I will get 2 and 2 cancelled. Mu into C into pi R2 square minus r1 square, right? Mu into c into pi r2 square minus r1 square, right? So we have got the equation of W and torque. Now the question is how you will find C. C कैसे मिलेगा? तो बेटा C कैसे मिलता है? Understand, in the question they will give you P maximum. Okay, they will give you P maximum. In question they will give you P maximum. So if you have P maximum, then you will put R minimum. So C is equal to P maximum into R1. ठीक है, ये रिलेशन हम यूज कर सकते हैं C निकालने के लिए. C will be equal to P maximum into R1. If you have P maximum in the question, then just use this in order to find C, then put C here and find W and T. Okay. Now beta, look at the equation of torque. Look at the equation of torque. This equation of torque can be written like this. T equals to mu into W into R. Okay. Mu into W is what? The friction force multiplied by radius R. So friction force multiplied by radius R. What I am doing here exactly? I am assuming that this entire friction force is acting at a distance R. That is not the case exactly. Okay, मैं क्या assume कर रहा हूं कि पूरा का पूरा friction force जो है actual में क्या होता है? Understand. Actually the friction force is distributed. Okay, actually the friction force is distributed like this. Okay, so the entire friction force is not acting at some distance. Okay, it is distributed from R1 to R2. But if I assume that the entire friction force is acting at one particular distance, पूरा का पूरा friction force जो है वो एक ही distance पे लग रहा है, one particular distance, that distance will be R mean. Okay, so what will be this R mean? Mean radius. If you compare this relation and this relation, if you convert this relation into this relation, then you will get R mean. Now how I will convert this into this? Understand beta, in order to convert this into this, I will have to write P in terms of W. Okay, so how I will write P in terms of W? P will be equal to what? W divided by pi R2 square minus R1 square, right? So T equals to mu into W upon pi R2 square minus R1 square into 2 pi R2 cube minus R1 cube by 3. ठीक है. Now in this case, I can write it like this. Pi cancel. This will become 2 by 3 R2 cube minus R1 cube upon R2 square minus R1 square. Okay. Now you can compare this with this relation. अब आप इस equation को इस equation से compare कीजिए. So what R mean are you getting here? What R mean are you getting here? R mean is 2 by 3 R2 cube minus R1 cube upon R2 square minus R1 square. R2 cube minus R1 cube upon R2 square minus R1 square. So what is this? This is known as mean radius of friction. Okay, so I am assuming entire friction force is acting at one particular distance. Now you will ask me, sir, what is the use of this? What is the significance of this? Why exactly we are calculating this particular parameter? इस चीज को हम लोग calculate क्यों कर रहे हैं? Why we are converting it like this? So understand बेटा, I will use this in order to find the difference between torque transferred by uniform pressure theory and uniform wear theory. If you want to compare the torque transferred by pressure theory and wear theory, then we will use this. Okay, so just wait and watch how I will compare the torque transfer. So this is the mean radius of friction in uniform pressure theory. Similarly, we can find the mean radius of friction in uniform wear theory also. Okay, so here in order to convert this torque in mu WR, I will have to convert C in W. And what will be C in terms of W? W upon 2 pi R2 minus R1, right? C will be equal to W upon 2 pi R2 minus R1. Okay, so I can put, this will become mu into W upon 2 pi R2 minus R1 into pi R2 square minus R1 square. Pi cancel. This will become mu into W R2 square minus R1 square. Can I write it R2 plus R1, R2 minus R1, A plus B, A minus B, A square minus B square. So beta A minus B and A minus B will be cancelled. I will get A plus B. So R1 plus R2 by 2. Okay. So beta from here, what will be mean radius? Mu into W into R, say if you compare it, then mean radius will be R1 plus R2 by 2. Average of R1 plus R2. R1 and R2. So here mean radius of friction is this. And here mean radius of friction is this. Okay. Now how I will compare these two? How I will compare these two? Understand. Uniform pressure theory versus uniform wear theory. What we need to compare? The torque transfer. Okay. So understand beta, in the torque transfer equation of both, mu and W are same. Only this mean radius is different. So if I compare the mean radius, I can tell which will give me more torque transfer, uniform pressure theory or uniform wear theory. Okay. So beta, mean radius of friction cannot be directly compared, because if you look at the equation, mean radius of friction uniform pressure theory से क्या है? 2 by 3 R2 cube minus R1 cube upon R2 square minus R1 square, and wear theory से R1 plus R2 by 2. So just by looking at this, can you compare? No, you can't compare. So what I will do, let R1 equals to 100 mm and R2 equals to 200 mm. Okay. Just assume some quantity, any quantity, 50, 100, 100, 200, 200, 400, assume any quantity. Let me assume this. Now tell me, what will be mean radius of friction according to uniform pressure theory? Pressure theory से कितना आएगा? Calculate it. 2 by 3 R2 cube minus R1 cube upon R2 square minus R1 square. So what you are getting? I am getting 155.55. And according to uniform wear theory, this is UPT pressure theory. According to uniform pressure wear theory, 1 plus 2 by 2, so it will be 150. So you can see that mean radius of friction according to uniform pressure theory is more, right? Or you can see mean radius of friction according to uniform wear theory is less than mean radius of friction according to uniform pressure theory. That means torque transfer according to uniform wear theory is less than torque transfer according to uniform pressure theory, right? Yes, very good, Ashok, very good, Nitish, Palak, very good, Utkarsh, Kalpesh, Pravin, very good, very good. Now beta, what does it mean? Let's say you need to design a clutch plate. मान लो आपको एक clutch plate design करनी है, okay? So you can use the two equations. According to you can use the equation of pressure theory, you can use the equation of wear theory. In order to design the new clutch plate, you can use equation of pressure theory or wear theory. Now which equation are we going to use? One theory will give you more torque than other theory. Okay, pressure theory will give you more torque, wear theory will give you less torque. So which equation are you going to use? Now a lot of people will say uniform pressure theory because it will give us more torque. But beta, you are forgetting something. You are forgetting something. The objective is not to get maximum torque. The objective is to keep the plate safe. So understand. Let's say you are using uniform pressure theory in order to design the clutch. Okay. Let's say right now it is transferring 100 Newton meter torque. You need 100 Newton meter torque. It is transferring 100 Newton meter torque according to pressure theory. But it will transfer 100 Newton meter torque only when pressure theory is applied. When uniform wear theory will be applicable, the torque will reduce, right? So when the clutch is new, you are safe. You need 100 Newton meter, you are getting 100 Newton meter. So when the clutch is new, you are safe. But when the clutch will become old, then you will fail because then the torque transfer will reduce. So beta, agar aapka torque transfer, if your torque transfer is going to get reduced later, then you will assume that that is my torque transfer, that is the maximum torque I can transfer, right? You will not assume the torque transfer you are getting initially because that is only for a very short period of time. Afterwards, you will get less torque transfer, right? So beta, if your torque is going to reduce after some time, then you will assume that that is my maximum torque transfer. And I have told you this concept before also. Whenever you have two different theories and you are getting two different loads from the two different theories, then which one will be safer? Less load, minimum load will be safer. And whenever you are getting two different dimensions, let's say you are calculating diameter and you are getting two different diameters from two different theories, then which one will be safer? The maximum one. So dimensions में safe dimension will be the maximum one. लोड में सेफ लोड विल बी द मिनिमम वन. ठीक है, अगर आपकी कैपेसिटी आगे जाके कम हो जाने वाली है, जैसे मान लो आप एक मजदूर को हायर कर रहे हो. लेट्स से यू आर हायरिंग someone for some labor work. Okay, let's say you are hiring someone for some labor work. Let's say you are hiring someone to move the load from one place to another place. Okay, in the morning he can move 50 kg load. Okay, at a time he can move 50 kg load, but after 1 hour, after only 1 hour, his capacity reduces to 30 kg. Okay, and then the entire day he will be only able to transfer 30 kg, move 30 kg. Then which load will you give him? 50 kg or 30 kg? You will not give him 50 kg because after only 1 hour that will reduce to 30 kg. Okay, so beta, if you are asking him to work for 8 hours, in 1 hour he will be only in 1 hour only he will be able to move 50 kg, but for the rest 7 hours he will be able to move only 30 kg one time at a time. Then you will give him boxes of 30 kg only na, in order to be safe. कि ठीक है, in 1 hour you just work for less capacity. Okay, but afterwards your capacity will reduce to 30 kg, so I will be safe. ठीक है, तो मेरे भाई 30 kg लोड ही आप उसको दोगे, क्योंकि 8 घंटे में से सिर्फ 1 घंटे उसकी कैपेसिटी 50 kg है, बाकी के 7 घंटे वो सिर्फ 30 kg उठा सकता है. तो अगर आप उसको 50 kg दोगे तो 1 घंटे तक तो आप सेफ हो, लेकिन उसके तुरंत बाद जैसे ही उसकी कैपेसिटी 30 kg हुई, आप दिए जा रहे हो उसको 50 kg, वो तो मर जाएगा ना. तो मेरे भाई आप चाहोगे क्या कि आपका मजदूर पहले ही दिन मर जाए? पहले ही दिन नहीं, पहले ही घंटे के बाद मर जाए, नहीं ना. तो मेरे भाई क्या करोगे, आप उसको शुरू से ही 30 kg दोगे, ताकि चलो 1 घंटा आप अपनी कैपेसिटी से कम पे काम कर लो, बट बाकी के 7 घंटे तो आप सेफ रहो. सो दैट विल बी योर चॉइस, राइट? मिनिमम लोड. सो बेटा, विच थ्योरी आर यू गोइंग टू यूज? विच थ्योरी आर यू गोइंग टू यूज? सो फॉर डिजाइन, फॉर सेफ डिजाइन, we use uniform wear theory as the torque transfer predicted by uniform wear theory is less. Okay, ये कम टॉर्क ट्रांसफर प्रिडिक्ट कर रहा है, तो इसी से हम डिजाइन करेंगे ताकि हम हमेशा सेफ रहें. जब आपका क्लच नया हो तब भी सेफ, पुराना हो तब भी सेफ. इज इट क्लियर? इज इट क्लियर? सो बेटा, यूनिफॉर्म वियर थ्योरी इज द थ्योरी विच वी यूज फॉर द डिजाइन पर्पस. ओके, वी डोंट यूज यूनिफॉर्म प्रेशर थ्योरी फॉर द डिजाइन पर्पस, यू यूज यूनिफॉर्म wear theory for the design purpose. Okay, now what questions can you expect from clutch? You can expect theory questions, the difference between pressure theory, difference between wear theory, you will get those types of question, and numericals, mostly numerical. Clutch se mostly you will get numericals, and that will be very formula based numericals. Okay, so you only need to remember the formula of these two, W and T. Okay, and you also have to remember these equations, this integration wala equation, this equation and this equation. These two equation also you need to remember. Why do you need to remember that? That I will explain later. When we will be solving numericals, I will tell you why remembering these two equations are so important. ठीक है, इन दोनों को याद करना इतना important क्यों है, ये मैं आपको बाद में बताऊंगा. जब हम लोग न्यूमेरिकल सॉल्व करेंगे तब मैं आपको बताऊंगा कि प्रेशर थ्योरी और वियर थ्योरी के अलावा भी, इससे जो इक्वेशन मिल रही है उसके अलावा भी ये दोनों इक्वेशन याद करना क्यों जरूरी है. ठीक है, इनके ऊपर भी हम न्यूमेरिकल करने वाले हैं. ओके, तो बेटा आज हम लोगों ने कॉन्सेप्ट पढ़ा क्लच प्लेट का, क्लच का. कल हम इनके न्यूमेरिकल्स करेंगे. टुमारो विल बी द डे व्हेन वी विल बी सॉल्विंग न्यूमेरिकल्स ओनली. वी विल बी ओनली सॉल्विंग न्यूमेरिकल्स, ओनली न्यूमेरिकल्स. ओके, एंटायर क्लच प्लेट के न्यूमेरिकल्स वी विल सॉल्व. ओके, सो बेटा टुडे we saw the theory part. Tomorrow will be the day of numericals. Okay, we will be solving only numericals. Okay, now beta quickly join this Telegram channel, because the entire notification and links you will get on this Telegram channel only. Okay, and don't forget about this tinyurl.com/approve10, because all the lectures, the links of the lectures, all the PDF, the links of all the PDFs, everything you will get here only. And how you will open this? इसको open कैसे करेंगे? Go to your browser and type tinyurl.com/approve10. Just like you type facebook.com, youtube.com, type this. Okay, don't search. Type tinyurl.com/approve10, enter, and you will open this. After opening this, you will know what to do. एक बार इसको open किया, उसके बाद आपको easily समझ में आ जाएगा कि क्या करना है. Okay, and if you want to study with us in a more personalized manner, then beta come to Unacademy Plus. Come to Unacademy Plus. On Unacademy Plus, what you are going to get? You are going to get the expertise, the guidance of the expert faculties. We have the most experienced and the best faculty pool ever. On Unacademy platform, you will get the best of the best faculties. So if you want the guidance of these faculties, if you want to ask your doubts, if you want to give weekly tests prepared by these faculties, if you want the crash courses by these faculties, then you will come to Unacademy Plus beta. Now, why Unacademy Plus? Taking subscription is important. Why? क्यों Unacademy Plus का subscription लेना अनिवार्य है, जरूरी है? It is not mandatory. See, a lot of people ask me, a lot of students ask me whether it is required to take guidance, whether it is required to take admission in some institute or not. So beta, I will tell you one thing. There is no exam in this world which cannot be cracked by self study. ऐसा कोई एग्जाम नहीं है जो सेल्फ स्टडी से आप क्रैक नहीं कर सकते. दुनिया का हर एक एग्जाम आप खुद से पढ़ के निकाल सकते हो. बट व्हाट इज द डिफरेंस बिटवीन सेल्फ स्टडी एंड दिस Unacademy Plus is, if you are on Unacademy Plus, you get the guidance of the experts. So whatever mistakes you are going to commit during your preparation by self study, you will not commit that mistake, so it will save time. अगर आप खुद से पढ़ते हो तो बहुत सारी गलतियां होंगी आपसे. कई चीजें ऐसी होंगी जो नहीं पढ़ना था आपने पढ़ ली, कई चीजें ऐसी होंगी जो पढ़ना था आपने छोड़ दी. तो बेटा वो गलतियां आप नहीं करोगे, आपका टाइम बचेगा, आपकी मेहनत बचेगी, क्योंकि यहाँ पे एक्सपर्ट्स जो हैं वो उन गलतियों को खुद कर चुके हैं और वो सालों से बच्चों को पढ़ा रहे हैं. उनको पता है कि बच्चे क्या क्या गलतियां करते हैं, तो वो आपको बता सकते हैं कि ये चीज मत करना, ये चीज मत करना, ये मत पढ़ना, ये जरूरी नहीं है, ये पढ़ के चले जाना क्योंकि ये एग्जाम में एक बार आ गया था. तो ऐसी चीजें अगर आपको पहले से पता हो तो आप वो सारी मिस्टेक्स करने से बचोगे, आपका टाइम बचेगा, आपकी मेहनत बचेगी. तो ये एक सिंपल सी चीज है बेटा कि आप जो गलतियां खुद से पढ़ के कमिट करने वाले हो और गलती कर करके जो सीखने वाले हो, वो टाइम आपका बच जाएगा अगर आपको गाइडेंस मिल रही है. अदरवाइज ऐसी कोई चीज नहीं है जो आप सेल्फ स्टडी से नहीं कर सकते. आई हैव ऑलरेडी गिवन यू इनफ मटेरियल इन ऑर्डर टू प्रिपेयर दिस सब्जेक्ट्स योरसेल्फ. अगर आप सेल्फ स्टडी करके पढ़ना चाहते हो बेटा तो आपको उसके लिए किसी को पे करने की जरूरत नहीं पड़ेगी. जो भी आपको चाहिए वो सब कुछ आपको यहाँ मिल जाएगा. Everything you need for self study I have given you, I have provided you. I have provided you free video lectures, I have provided you PDF, everything. So what extra you will get here? Beta, here you will get the experts guidance, and here you will get doubt solving. This is the most important thing. When you are reading something, see, you can read from the textbook also, but why don't we prefer textbook? Why do we prefer video lectures? Because beta, in textbook, whatever I will learn, I can learn better from video lectures. But by watching video lectures, sometimes we will get confused, sometimes we will have doubts. So in order to solve that doubt, we need the interaction with the guide, we need the interaction with the faculty, and that interaction is not possible here, but that interaction is possible here. You can interact with all the top faculties from Delhi, from Hyderabad. All those faculties are teaching here. You can talk to them, you can ask doubts with them, you can solve their weekly tests, you can get into their crash courses. So beta, this is a complete package. And if you want to go one step ahead, then you can take Unacademy Iconic subscription, where you will be provided a personal coach who will be there with you 24/7. He will prepare entire schedule for you. He will take one-on-one sessions. He will analyze your entire test marks, and he will prepare study material for you. Okay, so this is one step ahead of Unacademy Plus. Okay, what extra you will get on Unacademy Plus? How Unacademy Plus is different? So Unacademy is India's #1 learning platform right now, and how it is different, let's see. So there are features which will give you the benefit. The first feature which I want to discuss is live polling and leaderboard. What is this? Let's say you are solving an objective question in the Unacademy Plus class. So we will create these polls where you will have to answer this question in 30 seconds, 1 minute, 2 minutes. Okay. So beta, let's say you have answered A in 10 seconds. So beta, this leaderboard will show you your rank and your marks. How much marks you got and how quickly, your rank and your timing. How quickly you gave the answer and what is your rank among the other students. Okay. So what this will do to you? This will prepare you for the real life environment. Okay. Exam में भी आपको एक particular time के अंदर आंसर देना है, तो आपकी वो आदत प्रिपेयर होगी, आपको ऑब्जेक्टिव क्वेश्चन का आंसर देने की आदत डलेगी. ओके, देन सेकंड थिंग, लाइव इंटरेक्शन. व्हाट इज लाइव इंटरेक्शन? हियर यू कैन कमेंट in live in the class. Entire class will be 100% live. There will be no lag, so your teacher can watch your comments and answer your doubts then and there in live in the class. And if you have a big doubt which you cannot write in the comments, then you can take the picture of your doubt and you can send it to your teacher. So your teacher will answer that, your teacher will solve that. And there are dedicated doubt solving sessions. Dedicated doubt solving session means every fourth lecture will be a doubt solving class. So all your doubts will be answered, no doubt will remain unanswered. Okay, so this is the best thing. Then the best thing of Unacademy Plus, the most important thing is multiple batches. You can see the plus batches taken by the top educators. You can see me here. This is our batch of GATE 2022. Then there is batch of GATE 2021 by some experts. Then there is a rank improvement batch. Then there is ESE prelims batch, ESE mains batch, GATE 22 batch, 23 batch. There are different batches by different educators, and all these educators have years of experience. So beta, the best thing is one subscription and you can attend all these batches. You can follow all these educators. एक सब्सक्रिप्शन और आप सारे बैचेस का हिस्सा बन सकते हो, सबसे पढ़ सकते हो, ठीक है. एंड आप अलग अलग एग्जाम के लिए पढ़ सकते हो, गेट के लिए, ईएससी के लिए, पीएसयू के लिए, एमई के लिए, एक्सी के लिए, सबके लिए आप प्रिपेयर कर सकते हो. तो आपको करना क्या है? जस्ट ओपन योर अनअकैडमी लर्निंग ऐप. इफ यू डोंट हैव इट, इंस्टॉल अनअकैडमी लर्निंग ऐप, देन क्लिक ऑन गेट सब्सक्रिप्शन. यू विल हैव दिस पेज which will show you different subscription plan, 1 month से लेके 2 year तक का plan. Okay, I will suggest you take 1 year, 1.5 year or 2 year plan. Why? Because per month cost is very less and you will be able to take the advantage of multiple batches. जितने ज़्यादा batches उतना ज़्यादा advantage, ठीक है. तो आपके पास जितना लंबा समय के लिए subscription रहेगा, आप उतने ज़्यादा batches attend कर पाओगे, उनका फायदा उठा सकते हो. Okay, and if you use this code APPROVE10, you will instantly get 10% off, and 1 year subscription fee will become this much, 1.5 year this much, 2 year this much. Okay, so beta, use this code APPROVE10 to get 10% off, and you can pay this in no cost EMI. आप EMI में भर सकते हो, वो भी बिना किसी एडिशनल कॉस्ट के, ये फी, ठीक है। ये इतना अफोर्डेबल एजुकेशन हो गया है, क्वालिटी एजुकेशन इतना अफोर्डेबल हो गया है ड्यू टू अनअकैडमी, ओके। And don't forget to use this code. If you use this code, whenever you will use this code, then I will get the notification and you will be under my personal guidance. आपको मेरी पर्सनल गाइडेंस मिलेगी, मैं आपको पर्सनली गाइड करूंगा इन अ बेटर वे कि आप कैसे अनअकैडमी प्लस का फुल टू फायदा उठा सकते हो, कैसे अपने प्रिपरेशन को मैक्सिमाइज कर सकते हो, ठीक है। सो बेटा, डोंट फॉरगेट टू यूज दिस कोड, बी प्राउड टू यूज दिस कोड अप्रूव10. आई विल सी यू सून ऑन अनअकैडमी प्लस प्लेटफॉर्म, ओके। नाउ before leaving, please hit the like button, please share this link and subscribe to this channel and press the bell icon. Thank you so much for watching. I will see you tomorrow. Till then, bye bye, take care, good night.